Yes, now I am going to talk about the third type of interaction, stimulated emission. This is the third type of interaction which was predicted by Einstein. Einstein said that if the atom is in the excited state and there is an external energy light which is passing by, then it may happen that the energy light which is passing by may stimulate this atom to come down from higher level to ground level, and during that process the light energy emitted, and that emitted light will be such that it will be in phase with the incident light. That is, the incident light is stimulating the atom to come down from higher to lower level, and the emitted light will be in phase with the incident light. That is, both of them will be coherent, and this process is known as the stimulated emission. Now I can represent the stimulated emission by this symbol here. That is, atom is already in the excited state, for which I give an external radiation h nu. In the presence of this external radiation and stimulated by this, the atom comes down to the ground level with the emission of 2 photons, and not just 2 photons, these 2 photons will be coherent and in the same direction. And this is the main idea behind the production of the laser light, which is coherent and monochromatic and directional beam of light. Now, the rate of stimulated emission, that means the number of stimulated emission that will take place per second per unit volume, this is proportional to the number of atoms which are present in the upper level, because from the upper level the atom has to come down, so it is proportional to the number of atoms in the excited level N2, and it's also proportional to the intensity of the light U nu, because it is influenced by the external radiation. So the intensity of the incident light will also influence the stimulated emission, so it is proportional to U nu. Therefore I can say it is proportional to the product of N2 and U nu, or it is equal to the constant of proportionality B21 N2 U nu. So here if we look at the three processes, all the three processes happen in a material together. Okay, the probability of each process is given by their Einstein coefficients. Like we discussed, in induced absorption or stimulated absorption, the Einstein coefficient is B12. So that will decide how many induced absorptions will take place. Spontaneous emission is decided by the Einstein coefficient A21. So that decides the probability factor for spontaneous emission. Stimulated emission is given by B21. Okay. But if we look at the actual number of induced absorption that will take place, it is given by B12 N1 U nu. So it not only depends on B12, it also depends upon the number of atoms in the ground level N1 and also the incident light intensity U nu. Rate of spontaneous emission is given by A21 N2. So here again it depends not only on A21, it also depends upon the number of atoms in the excited level. Okay, then if we look at the rate of stimulated emission, it is given by B21 N2 U nu. Okay, so here it depends upon the number of atoms in the excited level as well as the intensity of the incident light. Later on we will see that actually the induced absorption and spontaneous emission are more dominant process, and compared to these two processes, the stimulated emission becomes a very weak process. That means the stimulated emission will be there in every material, but the amount of the light which is emitted by stimulated emission will be very, very negligible. That's why we will not see the laser light emission in the natural sources.